Hello friends, now we are going to start with the practical part of multi-threading. This is the practical part 1 we are going to see. So we will see now how to create threads and handle threads. Same examples will be taken that were in the PPT slides. We will start with the main thread. For that purpose, we will create one example that is called current thread or main thread. I will create a package as usual. And new class as current thread demo. It can be same as a project name. Okay, this is no problem. Now I will have main function over here. So main thread always exists, but to handle it, we have to use one function called thread.currentThread. So we will start with thread t is equal to thread dot get current thread or current thread. This will return me main thread. So for that purpose, I have to return now. I print current thread. Its name, original name, that is with associated with T. Now I will change the name of thread. I rename it as my thread. After name change, I can print it out. After name change, I will print T. Try. For 5 times, I will print N and thread dot sleep for 1 second. Okay. So this is just for sake of understanding how we are using the sleep method. Okay. And in this, I catch interrupted exception, which is compulsory for catching interrupted exception E. Why? Because we are using the sleep method. Okay, the sleep can be interrupted at any time by any other thread or by us. So it is compulsory, it is mandatory to use the catch the interrupted exception. Main thread interrupted. Okay, now we will run this one. Current thread is After halting of 1 second, it is displaying the output. Okay. Now we will again run this. Okay, this way it is executing between with the 1 second halt in between. Okay, so this way we have understood how to handle the main thread or current thread. Now we will see how to implement the runnable interface. So there are two ways we have already seen: implement runnable and extending thread class. We will first see the implement runnable interface demo. New package. Will have my main method. So in this program, we are going to see, we are going to create another thread other than current thread, that is main thread. Okay. Why we have given the name as new thread? Because it is a class that is responsible for creating new thread each time. So we will understand by using this new thread name that this class is only designed for creating thread. Why? Because it is implementing the runnable interface and it has to implement, it must implement its run method. Okay. Thread, then new thread, default constructor, create new second thread here. So how you will create it? T is equal to new thread. And we can give it as name as this demo thread. Child thread plus T. Now here we are starting the thread. After start, what will happen? It will invoke the run function. And this is the entry point of thread. Here public void run. If you are not writing it over here, you can right click over here and add unimplemented methods. Sorry, not right click, just place the cursor. Do not click on it, just place your cursor over here and click on add unimplemented methods. It will automatically create the overridden method. Okay. Before this, you can put a comment, entry point. Okay. So it is auto generated method declaration in try. What we are doing? For 5 times child thread we are printing. For int I is equal to 5, I greater than 0, I minus minus. Child thread plus T. Sorry. And this thread will sleep for thread object will sleep for 500 milliseconds, which is long. Now I catch the interrupted exception because I am using the sleep method. And after it is done, all the operation is done, I am printing child thread exited. Exiting child thread. Now we are going to main class, that is thread demo. Here create a new thread, new thread. The object of new thread is created. Then try. After new thread creation of object, what will happen? It will go here and it will start. If you are not writing here start, you can write it as new thread n is equal to new thread, and then you have to call it as n dot start. Okay, but since we are starting the thread from this constructor, default constructor, it is okay that you are not writing start. But this line is very much important. If you will not write this, the thread will not execute. Okay, nothing will happen in your program. Now again here for main thread, for 5 times int I is equal to 5, I greater than 0, I minus minus. What I am doing? Main thread plus I and thread dot sleep for 1 second. And also here interrupted exception. Interrupted exception E. Okay, and main thread interrupted. And after all the operation is done, after catch, I'm writing main thread exiting or exiting main thread. Anyway, you can write main thread exiting. Okay, so now what will happen in this case? We have already learned in this PPT video the theory part. Main thread will sleep for 1000 milliseconds, that is 1 second. In that period of time, two child threads will be executing, and the output will be 2 child threads, then 1 main thread, 2 child threads, then one main thread, and after 5 times main thread is over, after 5 child thread is over, main thread will exit at last. Okay, so this way we have understood the implementing runnable interface and create a thread. Now we will see the second way of creating threads, that is extending thread class. Now we will close this project. Thread with extend thread dem. Thread is a class. Its name should start with capital, and I will finish this. Now, what I will do, I'll right click over here, new package for extend thread. Okay. Now, new class. With main. Here also we will have the class new thread, but here we will not implement runnable interface. We will extend thread class. Okay. Okay. So default constructor as usual, new thread. Why we have used here super? Because we are extending, and in inheritance we have learned that in all the child classes constructor we must call the super, so that all the values will be initialized from the base class. Why? By using super. So child thread will be printed using this because it itself is a thread. It is extending the thread class. So it itself is a thread now. And after that, what we'll be doing? Start. Look the difference between when we are extending thread class and when we are implementing the runnable interface. Now, this is extending a thread class. Okay, so this class itself is a thread. Okay, and for that purpose, here also we are not using the T to display the child thread, and here also we are not writing it like this, T dot start. Why? Because it does not need it. Start can be directly called because this is itself, it is now thread. Why? Because it is extending the thread class. Next is public void run. As usual, entry point for the second thread. Try. 5 times I am printing child thread as usual. For integer phi is equal to 0. Sorry, I is equal to 5. I less than greater than 0. I minus minus. Child thread plus I. Okay. And after that, I will be sleeping for 500 milliseconds as usual, as in the previous example. Thread dot sleep for 500 milliseconds, that is half of the second. And catch interrupted exception E. Okay. After this, or you can write it as child interrupted in between, or only child interrupted. After this, child exiting. Now we will go to the main class, and here also we will create the object of new thread. Now in try of main, we will write for in 5 I is equal to 5, I greater than 0, I minus main thread plus I, main thread plus I thread dot sleep. Catch interrupted exception, and here main interrupted, main thread interrupted, and main thread exiting after catch. Now we will run this, same output will be there, only the difference is we are extending thread class. Okay, so this way we have seen the both way, but in our sessions we are going to implement the runnable interface for all the examples. Now we will see how to create multiple threads. As far we have seen only main thread and one child thread creation. Now we will create multiple threads in our program. For that we will create a program called multi-thread demo. Why? Because our motto is to learn multi-threading. The topic is multiple threads should be there and we should be able to handle them. Package multi-thread demo. Now new class. With main. Now we will create a new thread that implements runnable class. New thread implements runnable. and add unimplemented method public void run. Before that, I create string name thread t. New thread string name 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 is equal to thread name. Is equal to new thread this dot you can name. You can also pass here name, but since we have initialized already this name, you can pass over here as name. You can also pass it as thread name. Both are same. Okay, it will not give you any error. But since we have already initialized, we are using the name. Then what we are doing? Printing new thread. New thread. T and T dot start. Starting the thread in the constructor itself. Okay. Then public void run auto generated method stub is also already created. What we have to do is we have to write the for loop as usual. For int I is equal to 0. Sorry, I is equal to 5. I greater than 0. I minus minus. Name name should be our thread name plus colon plus then thread dot slip here we are using 1 second between each and every thread. Around with try catch that we have forgotten. So unless we will use try and catch interrupted exception. Okay, and which thread is interrupted, we will understand using name interrupted, because for that purpose only we have given a name. Each thread will be given a name while creation, so that we will understand which thread is halted in between or interrupted in between. One interrupted or two interrupted. For that purpose we are specifying here name. And which child is exiting. In previous examples we given the child thread exiting and main thread is exiting. Why? Because there was only one thread. But in this case, from this case onwards, what we are doing, we are creating multiple threads. So we need to understand which thread is operating, which thread is halting or interrupted in between or exited. For that purpose, we are giving a directly name. Name exiting. I can give a space over here to stop. What? Better viewing. Then main, we are going to create 3 threads. New thread 1. It will not give you error because parameter can be same. Okay. 2 and 3. Now in try. I will wait for other threads to end. Thread dot sleep for 10 seconds. Wait for other child threads to end. Okay, and sleeping for 10,000 milliseconds, that is 10 seconds. Here also interrupted exception. It got main thread interrupted. We can directly give it as a name main thread because it is the main thread. Okay, its name is by default main only. And main thread exiting. Okay, now I will run this project. Okay, I will run it again so that you can view it better. 1, 2, 3 is created. 1, 2, 3, 1, 2, 3, 1, 2, 3. After all are finished, after 7 seconds, I guess 7 no. 5. After 5 more seconds, main thread will be exited. So this way we have understood multiple threads creation. Now we will see the example. In the same example, we will see using is alive and join. We will just modify this code, new thread, so that we will be able to handle this. Object 1 is equal to new thread 1, like this. Object 2 and object 3. Here it will give you error. Why? Because two objects name cannot be same. Now we will print it. Okay, whether they are alive or not. Object 1, thread 1 is alive. Object 1 dot t dot is alive. Same way we can print if all are alive. Thread 2 is alive, yes or no, true or false will be printed. And 3, object 2 dot 3 is alive, t is alive. Object 3 dot t is alive. Now we will wait for another threads to finish. Okay, this I will comment it out. Wait for threads to finish. how to do it. Object1 dot t dot join. Object2 dot t dot join. So wait for this thread to die. What will this join do? It will wait for this thread to die. And invocation of this method behaves in exactly the same way as invocation join 0. Okay. So join 0 and join are same, and it throws the interrupted exception. If any thread has interrupted the current thread, the interrupted status of the current thread is cleared when this exception is thrown. Okay. After interrupted exception is caught, interrupted status is cleared. It is again set to false. Object2 dot t dot join and object3 dot t dot join. 3 dot t dot join. So waiting for other threads to finish using join method and catch interrupted exception E. Here main thread. It is same as main thread waiting sleeping for 10,000 milliseconds or 10 seconds. Instead of writing this block, we have commented this and we are writing this block. Okay. The operation is same. Main thread interrupted. This is the better way to wait for other threads to finish, because every time main thread may not be knowing how much time it will be required to all the threads to finish. So it is better to use the join. After all will be finished, main thread will be waiting and then it will be finishing. Now again we will check if 3 are alive or not. And then I will exit the main thread in last, because it has to do all the shutdown operations. If main thread is shut down first, all the threads will be keep alive forever, or they can be in corrupted state. All the file handles like confidential data structure, critical data structure will be open in forever state and they can be corrupted state. Main thread exiting. So main thread exiting last is very much important thing in multi-threading. You have to take care of it. Now I will run this demo project. Okay, this is the output. Three are alive over here. It will check, wait for other threads to finish. After all the operation from 1 to 3, in the PPT we have seen the output that was different. One was created after this message, but here we are viewing this is created first. So it is dependent upon the processor speed and task load. For everybody output may be different, but this will be same. Is alive will be true. After join, is alive will be false, and after then only your main thread will be exiting. So is alive and join will take care that your main thread will exit last. Now we will see one more example of thread priority. That is the clicker example we have seen in theory part. The same example we will see here. thread priorities demo. New package for thread priority. Then new class. With main method. Now class, same example I am taking over here from the PPT video. Class clicker implements runnable, add unimplemented methods, public void run. Integer click is equal to 0. Then thread T. Private volatile boolean running is equal to true. Parameterize constructor. T is equal to new thread. This. Then T dot set priority P. Whatever priority we will be passing over here in the constructor while creating the object of clicker class, this will be set to this particular thread. Then in run, what we are doing while running, that is while running is equal to true. While running, what we are doing, click plus 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 plus, then public void stop. We are creating this method. Then running is equal to false. Public void start. T dot start. We'll start the thread and call the run method. And after call, click will be incremented by 1. Now, thread dot current thread dot set priority. This will be thread dot max priority. Clicker high priority is equal to new clicker. New clicker thread dot norm priority plus 2. This will be my high priority, that is 7. Norm priority is 5 by default. Then clicker low is equal to new clicker is equal to thread dot norm priority minus 2. This will be my low priority object of clicker. Now, first of all, I will start low. Low dot start. Then high dot start. Low priority thread is started first. Then thread dot sleep. How many seconds? 10,000 milliseconds. Catch interrupted exception E. Main thread interrupted. Main thread interrupted. Then first of all low dot stop. Then high dot stop. Wait for child thread to finish. Then try object high dot t dot join low dot t dot join. Both will be exited. Again catch. Again interrupted exception. Interrupted exception caught. Then we are printing the output. Low priority thread low dot click and high priority thread high dot click. Now I will run this code. Okay, as we have seen, the output we have seen in the PPT part video, that was different and this is different. Okay, so every time output can be different. Again I will run this. Again I will have the different output. Okay, so this way we have understood the priorities of threads. In the next upcoming sessions, we will try to cover all the remaining examples. So meet you in the next session. Thank you so much.